Hello and welcome to Group 29's robot demo video. Today we'll be showing you our robot, which is split into four main components. The first one being the control phone app, the second one being the robot, the third one being an RPI circuit diode server, and the fourth one being a Google Firebase database that takes control of all the data passing through. So we'll begin by showing you our phone app first.
The first component of our robot is the application, which serves as a connector between the Firebase database as well as the server connection through the socket I/O. When the app is booted, the user is presented with the main screen, which consists of statistics, the possibility to configure a bug, view all of the bugs that are registered inside of the database, and calibrate the load cell, as well as choose on what the bug should be sorted on, and see the warnings that might occur during the sorting process. When the user enters the View My Bugs screen for the button, then he's presented with all of the bugs that are present inside of the database and are also configured. So he can see all of the characteristics and fields which a specific bug has and which are input by him in the earlier process. The user is also allowed to configure a bug, which is either already present bug inside of the database or a new bug he wants to input. While going into a specific bug, he's presented with the pop-up that says that the bug is already present inside of the database, and he can input the name. So now let's add a new bug inside of the database with some given name. Let's choose the flight number to which this bug can be assigned to, the ticket class, and also we can check whether the bug is a connection flight or whether it is an illegal bug. And now it should be added inside of the database, so let's check it. And as it can be seen, it's here. Okay.
Now we're going to move on to demoing the actual functionality of the robot here. We're going to go through sort of the main scenario for sorting luggage. So over here, if my assistant zooms in, we have 4 marked luggages, which you can also see here in the database. If I click through them, these are the luggages 0 to 3. So as you can see, if you look at this field, each luggage is marked with a different flight. Let me just try to go through here. This one is marked differently. This one is flight 3, and this one is flight 4. So they now currently we are sorting on flight, and so each luggage should go to a different bucket. The way the sorting process works is we take a luggage. This one should go into the illegal bucket, which is here. Then the buckets are numbered. This one is the illegal one. This is bucket number 1. This is bucket number 2, and this is bucket number 3. So in theory, we should get this one in the illegal bucket. This one bucket number 1. This one bucket number 2, and this one is number 3. Okay, so now we're going to insert this luggage, which is marked as illegal, and hence it should go into the illegal bucket, which is over here. The way the insertion works is you open up this flap, place the luggage onto the load cell, wait for the robot to respond. This servo actuates and sends the luggage onto the conveyor belt, where it is moved to the RFID scanner. Here it is scanned, some database server communication goes on to determine the bucket, and then once it's processed here, the ultrasonic sensor is triggered and the luggage is inserted into the bucket. Okay, so we're going to move on to these other two. Again, I'm going to just insert this one. This is luggage number 2, so it should go into the second bucket. And once it's scanned, the sorting wheel rotates to the correct bucket. And then as you can see, we again have a faulty detection, so luggage does not be detected, but we do again solve this with the timer. Okay, so we move on to inserting the third bag. We're just going to go through the same steps. And this bag should be inserted into bucket number 3, which is over here. Again, we have this faulty sensor, but we deal with this with the time at fault, and we also obviously detect it through the timeout from the app. So again, we got a new timeout notification, which is over here. Same thing. We're going to attempt to showcase the ejection mechanism. Over here we have a luggage that we have loaded up with some screws to make it overweight, and this luggage should hopefully be rejected by the system. So if I try to place it here, the thread is overweight and is ejected by the system. Okay, so as you can see right now, we are getting a light fault concerning the load cell. It says that the load cell is giving erroneous readings, and this is a perfect opportunity to demo our calibration routine. The way the calibration routine works is in the app, the user says that they want to calibrate the load cell, and then they input the weight of an item which they know the weight of. In this case, we're using these Samsung Galaxy Buds, which we know weigh 51 grams. After user has done this, they press the calibrate button, and here we are told to remove any known weights from the scale, which we have done. The scale is empty. And now, after we have done so, we press yes. We should get a new notification soon telling us to put yes. So we are supposed to input the calibration item. So we're going to do so. We're going to take the Galaxy Buds and put them onto the load cell and close it. Now we got a new notification. Still about the erroneous readings actually. We say we have inputted the item. And after this, the item is supposed to get ejected. Of course, it got stuck here a little bit, but I can see it now. We actually got a correct reading from the load cell.
Now we're going to talk about the communication between all those three systems. So this whole communication is made throughout a socket IO server, which is hosted on our Raspberry Pi. If I just run this command over here, this launches our server to a dedicated IP, which then also gives us logs about all the faults and all the things that happen. As you can see here, the first device got added, the ESP32, and as soon as we open the Flutter app, we can see the new device got added as well.